So there's this thing called Q. And Q is found the exact same way that we find Kc. Except for one difference, which is that with Kc, we know that we are using equilibrium values. We know we're at equilibrium if we're plugging into Kc. With Q, we set it up the same way. We still do products over reactants, coefficients become exponents, but Q is we are not sure if our values are equilibrium values or not. We have these values and we want to test, are we at equilibrium? Let's say I had a reaction like, really basic, A plus B goes to C, and I know that the K value for this reaction is 2. If I say if the concentration of A is 3, the concentration of B is 1, and the concentration of C is 6, is the reaction at equilibrium? Well, if these are equilibrium values, when I plug them into products over reactants, I would get 2. I'd know I'm at equilibrium. If I don't get 2, I know I'm not. So we call it Q, but it's set up the same way. Products over reactants. I don't know if they're at equilibrium. That's the only reason I didn't call it K. I plug my C value in. I plug my A value in and my B value in. And sure enough, I get 2. So yes, with those concentrations, this reaction's at equilibrium. That's finding Q. That's it. It's not actually mathematically different. What I can do, though, is let's say I had different values. So same reaction, same K value, but now, let's say A was 1 and B was 2. So I set up my Q, products over reactants, I plug in my value of C, I plug in my value of A and my value of B, and I solve, I get 3. Well, for Q I got 3, Kc is 2. This does not equal 2, so we are not at equilibrium. If we were at equilibrium, we would have got an answer of 2. Then I can ask you, like a part B to this question, could be which way will it shift? My answer choices here are left and right, which is weird. So think of the reaction. These are my reactants. They are on the left, literally on the left side of the arrow. See, these are my products. They are on the right. I'm going to pause and make sure that didn't get cut off. So when I set this up, I set up products over reactants. And what I got is bigger than Kc. That means this number is too big. That means my products over reactants, that ratio is too big. You can think about it either in terms of the products or the reactants, but most people are more comfortable with a fraction looking at the numerator, so looking at the products. If overall this value is too big, that means overall my products are too big. I have too many products. If I have too many products, that's like saying I don't have enough reactants. So I'm going to shift away from the products towards the reactants. I want to get rid of some of my products and make more reactants. My reactants are on the left, so I am shifting left, simply because this number was too big. If this number were too small, that would tell me, oh, I don't have enough products. My products are too small. I would want to make more of them. I would shift towards the products. Yes, for sure, you could just memorize that if it's too big, we shift left. And we know it's too big because it's bigger than Kc. But you need to be able to explain, too many products or not enough reactants, shifting towards that side.